In this lecture, we're going to deal with our third chain in condition, the effect of increase or decrease in concentration of either reactants or products on the equilibrium. We're going to see how by changing the concentration of reactants or products, how would the equilibrium change? How would it be affected? So let's think of an example. Let's say we have a reaction in which we have hydrogen and it is reacting with iodine and it is producing two molecules of hydrogen iodide. And the reverse reaction is also happening. Two molecules of HI are decomposing and they are producing H2 and I2. So this reaction is an example of a reversible reaction, and in this case all of them are in gaseous state. So let's write that down as well. These are all in gaseous state. Now what's going to happen if I increase the concentration of H2? Let's say I increase the concentration of H2, and the square brackets represent, whenever we write square brackets in chemistry, it represents that we are talking about concentration. So let's say the concentration of H2 is increased. Now if I say it is increased, that means that since the concentration is high for H2, there are more particles. Now that means that there are more particles of H2 per unit volume. So since there are more particles, there would definitely be more collisions between H2 and I2. It's going to result in more collisions. So you'll have more collisions, and we all know that if there are more collisions, then a faster reaction is going to take place. So we'll have a faster reaction. But which reaction would be faster? It's the forward reaction that's going to be faster. We're not touching the concentration of HI. So the reverse reaction would occur at the same pace. It's only the forward reaction that's going to be faster. So let's write that down as well. This reaction would be faster compared to the backward reaction. So what we're going to say now is that if I increase the concentration of H2, then the forward reaction increase, forward reaction speeds up, or we can say that the equilibrium shifts or favors or we can say it favors the right hand side or we can say it favors the products. So more HI is going to be formed because the forward reaction is faster. And we can now also discuss how this applies to the Le-Chatelier principle. The Le-Chatelier principle was that the equilibrium basically counters any change that is introduced. So we increased the concentration of H2. We are increasing the concentration of H2. And since the forward reaction speeds up, there's more HI being formed. So H2 would be consumed at a faster rate, which is, so how is the equilibrium doing the opposite? It's trying to decrease the concentration of H2 back again by favoring the forward reaction. More HI is produced, less H2, the faster H2 would be consumed. So if I increase the concentration of H2, the equilibrium does the opposite. It tries to decrease the concentration of H2. So now vice versa, if I let's change the concentration of some other substance. Let's say I decrease the concentration of I2. So the concentration of I2, I'm decreasing it, is decreased. So if I decrease the concentration of I2, there will be fewer particles of I2 per unit volume. And since we'll have fewer I2 particles, there would be lesser collisions. So we'll have lesser collisions. If we have lesser collisions, the forward reaction in this case, it would be slower in this case. So the forward reaction would be slower. And the backward reaction, we're not touching the concentration of HI, so there won't be any change in the backward reaction or the speed of the backward reaction. So we're going to say that if the forward reaction slows down, what we can say is that the backward reaction relative to the forward reaction is now relatively faster. So what we're going to say is that if we decrease the concentration of I2, we can say that a forward reaction slows down, or vice versa. What we can say is that the backward reaction speeds up. And we're talking about the speeds in relative terms. We are only comparing the two reactions. Faster means that this reaction is faster compared to the forward reaction. So the forward reaction slows down, which means the backward reaction is now relatively faster compared to the forward reaction. And if the backward reaction speeds up, then more H2 and I2 would be produced. So more reactants would be produced. So what we can say is that the equilibrium shifts and favors the left hand side. So it's shifting and favoring the left hand side or the reactant side. We can also write down the reactant side. In this example, this is another example of another reaction which is part of the Haber process, and let's talk about products now, changing the concentration of our products. Let's say I decrease the concentration of NH3. So the concentration of NH3 is decreased. Now if I decrease the concentration of NH3, what's going to happen? The forward reaction, the speed of the forward reaction, your forward reaction and its speed depends on the concentration of hydrogen and nitrogen. Now that is unchanged. So your forward reaction, the speed of the forward reaction would not be affected. But the speed of the backward reaction, that would definitely slow down. It slows down. So the speed of the backward reaction slows down because you have fewer particles of NH3. You have fewer, the concentration decreases, so you have fewer particles of NH3, which would result in fewer collisions. So your collisions would also decrease, which would result in a decrease of the backward reaction. So your backward reaction would slow down. And in relative terms, your forward reaction would be faster. So we're going to write down that in this case, your backward reaction slows down. So backward reaction slows down, or vice versa, we can say that the forward reaction speeds up. And if the forward reaction speeds up, more NH3 is going to be produced, so more products are produced. So we're going to write that equilibrium shifts to the right hand side or vice versa, we can say that equilibrium favors the product side. And if you look at the Le-Chatelier principle, which said that the equilibrium counters the change that is introduced. So if we decrease the concentration of NH3, if I decrease the concentration of NH3, more NH3, more products are produced. The forward reaction speeds up, so more products produced. So the equilibrium shifts so that it increases the concentration of NH3. So the Le-Chatelier principle is again proven right.